Welcome back to the second part of today's lesson. Yesterday, you've gotten exposure to how to solve cosine functions using the arccosine function, which is really just a formula involving inverse cos. And earlier today, arcsine, second part of today's lesson, we'll undo tangent with something called arctangent to find all solutions. And in general, what we found was by adding and subtracting the inverse cos, we found two solutions that if we add 360, we can find all solutions, and that had to do with some symmetry we found in cosine. Likewise, for sine, there was some symmetry that allowed us to do the inverse sine as well as 180 minus the inverse sine, and add or subtract periods to that, whether it's in degrees or radians. And today, we're going to do this for tangent, and to get started, we'll have a quick look at sine again. Remember, sine's formula has slightly different format than cosine, so it's good to get some exposure to this. We undo sine with arcsine. If we do it to one side, we do it to the other, and we get theta equals the arc sine of negative 1/2. The question here is, where is sine negative? Our equation is going to look like the inverse sine of negative 1/2 plus 360n, and 180 minus the inverse sine of negative 1/2 plus 360n. So there are two pieces to this. Sine is negative below the x-axis, and opposite is negative 1/2 on these triangles, and that makes me think this angle here is negative 30, and if I did 180 minus negative 30, that's 180 plus. That would get me around to that spot. So that would be the general solution, but I want to find values from negative 360 to 360, so I'll use my general solution to find values in the interval given. Negative 30 works, and if I add 360 to that, I get 330, and that angle works as well. If I subtracted from negative 30, I wouldn't be within this domain down to negative 360. I'd get beyond that. So there's two values, and then I do 210. That one's in my interval. If I added 360, I'd get beyond my positive 360. So I'll subtract 360 and get negative 150. And there's my solution to this problem. Now tangent is going to have some similar properties, but tangent works a little differently than sine and cosine. If we want to try to find the general solution for tangent of theta equals 1, we would look at where tangent's positive. In this case, tangent is positive in first and third quadrants. All scholars take calculus. And it's equal to 1 where opposite and adjacent have equal lengths. Well, that's a 45-degree angle, a root 2 over 2 and a root 2 over 2. Or a negative over negative is positive as well. So a similar reference angle. So if we want to undo tangent to find the angle, we look at this and say theta equals the inverse tan of 1. And we just realize that it's 45 degrees. Now that gives us this first angle here. If I want to get around to the second spot where tangent's positive, I can add 180 degrees, or I could subtract 180 degrees. So a general format would give us plus or minus 180, or plus 180n, where n can be a positive or negative integer. And there's our general solution. So for solving tangent theta equals a, just the simplest form, or tangent of x equals a, we'd simply take the inverse tan and not have to put a plus or minus in front, and don't have to subtract it from 180. But now, to get our multiple answers, we're going to add 180, not the 360, or pi instead of 2 pi. So very similar format, but definitely distinct from the other two general solutions. And to point that out, just remember, cosine will have that plus or minus in front. It'll be a single line. Tangent won't have anything out in front, but it will be a 180 instead of a 360. And then sine, slightly different because it takes two lines, an inverse sine and a 180 inverse sine. And then it's got the same kind of period as cosine. So there's all our solutions. Now we're going to get to work on these and put them into practice. We'll focus on tangent, obviously. Similar problem to the one you just did. We're looking for values where tangent is negative, and we're going to pin it down to an interval from 0 to 720. Well, tangent is positive in the first and third. It's negative in the second and fourth. And again, that -1 comes from equal sides being divided, opposite over adjacent. Doesn't matter if it's the numerator or the denominator. If one of them's negative, the whole answer is negative. And so we get arctan of theta on both sides. We take arctan, we get theta equals the arctan of -1. And that gives us theta equals, in this case, that angle would be a -45 degrees. So -45 degrees plus 180 n. That's our general solution. We want to pin this down for just 0 to 720. Unfortunately, our first angle, -45, isn't in the interval, so -45 doesn't work. But if I add 180 to -45, I get 135. That certainly works. If I add 180 again, I get 315. Adding 180 again, and once more, $675, I believe. And so there's our answer. Why don't you try this one, hit pause. This comes from some of our trig exact values. We'll do some calculator-based ones in a moment. All right, I hope you've been able to get an answer or at least come to a point where you know you have to fill in some gaps. We're going to undo tangent with arctangent. And we get theta equals the arctan of √3. Root 3 can be thought of as √3/1. We want positive values again. And opposite √3/1 or negative √3/-1 will work. Recognizing the √3 being larger than 1, from a 30, 60, 90, that's a 60-degree angle, so theta equals 60 plus 180 n. General solution. Now, for this answer, it'll be 60 degrees. Adding 180 is 240, 420, and 600. There's our answer. Hopefully that's where you got to. If not, make sure you think about the steps that you need to fill in for. This will be a calculator problem. We're going to undo, actually we don't have to undo, the first step's been taken. You can think of this problem as having started here, and we undid tangent with arctangent. So using our formula, we'll take x equals the inverse tan of 4.3 plus 180. Whoops, not plus 180, plus pi, since we have radians here. So I go to my calculator, go to radian mode, and take second tan of 4.3. 1.34, okay, so we'll call that 1.3. And just to get a reference on that, if we look at where 1.3 would appear, if this is 3.14, 1.3 would be a little more than a third of the way, so it'd be up here in the first quadrant. The answer is definitely positive. That's a good thing. And from there, I just have to trust that this is going to work and be the correct value, but at least it's reasonable since it's positive. So x equals 1.3, I'll call it, plus pi n. And on the interval 0 to 4 pi, it's 1.3. And then I'm going to do some adding here. Plus pi 4.5 6 7.6, and 10.8. Now, just to make sure I've got an interval that's good, or at least my answers are still within the interval. 4 pi is like 4 times 3 and change, so that's a 12 point something. 12.4 something, call it 5. So 12 and a half roughly. And 10, if I added 3.14 to this, I'd get above it, so looks like a reasonable interval. Now let's have you try this. Go ahead and get started, and we'll go from there. Please remember now we're in theta, it's degrees, and we're allowing negative 360 to 360. Okay, hopefully you were able to get a good start on this. We know that theta equals the inverse tan of 9 over 4, in this case plus 180n. And I need a calculator for the inverse tan of 9/4. Oh, but I also need to be in the correct mode. So 66 degrees. I can quickly notice that 1.15 radians should be roughly 66 degrees, and that seems reasonable to me. It's about a third of the way over. So theta in general equals 66 plus 180n. That's our general solution. To get my specific solution, I'm going to get theta equals 66. I add 180, I get 246. If I go any further, I'm going to get beyond my 360, so that's it on the plus side. Now I start subtracting 180s, and I'm not going to take a chance. I'll go 66 minus 180 and get negative 114 and minus 180 again. So here's all my answers, not in a nice order. I didn't go from least to greatest, but there's the values. Hopefully that was a good start for you. Here's the on your own problems. Go ahead and give these a try, and we'll talk in class.